Okay, so in this video, we'll talk about what is ComfyUI, what is Stable Diffusion, what is the background behind it, and this is a series of ComfyUI where I'll teach you everything from start to end. This is the first part of the series of ComfyUI where we'll talk about what is Stable Diffusion, what is ComfyUI basics, and understanding of fundamentals, so we can upgrade our knowledge till the advanced. So this series is a full advanced series where we'll start with basics and fundamentals. Then we'll go on another part of the series. So I'll quickly share my screen and show you the agenda of our class. Okay. Uh, mm, 1 minute. Yeah. Okay. So in this video, we'll talk about how stable diffusion works and what is stable diffusion actually. Then we'll talk about what is ComfyUI. Then how you can set up that ComfyUI in your local PC, or you can use virtual clouds model to use ComfyUI. And at the end of this video, we'll talk about how a basic text to image workflow works in ComfyUI. So let's deep dive in. So I prepare a full chart how stable diffusion works. So basically, stable diffusion is a latent diffusion model that generates AI images from text. So to understand its basics, so basically it's a text image generation model that works on diffusion models. So diffusion comes from a physics terms where so if you drop a ink in a water, then it's diffused dissolve in water. So it's called diffusion. So there's that terms came in. So if you can see, I have put in a screenshot how a stable diffusion works. So suppose if we put in a image prompt that Teddy bears wearing suit discussing a business proposal around office table. So a stable diffusion works just like predict the images on top of this image. So it predict the teddy bears, business proposal, office table, and discussing. So if you see, it's teddy bears, office. That means you see office. We are talking about office table and business proposal. So you can see there's a tie in it. There's a suit and tuxedo and all, and you can see a table. So this is how. So how this works? So this works on two things: forward diffusion and reverse diffusion. So first we need to train the model how to predict these things. So how these things predict? So suppose there's a cat image. So we put in thousands of images of cat, put in a model that this is the scenario. Suppose it's cat in. So this is a black cat with brown eyes. So we put in these things. Then what model do? Uh, Take a picture of that, take the image you put in and convert the picture into pixels, latent pixels. So if you see it converting images into pixels. So see, first it convert into this pixel, then adding more pixels, then adding more noise. So this is called noising the images. So noising the images is basically when you try to train the model. And the same work when you try to generate a image from a model. So this is called when we try to generate images using text, using prompt. So this works. So the same. So the model start with a basic pixel image, completely pixelated, noisy image, and try to remove noise from the images. So first it try to denoise, then it try to denoise again, and try to denoise again. This is called denoising the pixelation. So this is how our stable diffusion works. And the step I was talking about. First step, it's taking the whole noisy images. Then second step, predict the noise. How it's predict the noise? Because when we are training our models, we are giving, okay, these are the images of dogs, these are the images of cats and other things. Then this model, feed the data, and when you are putting that keywords, then try to predict, okay, this person or this prompt is trying, this person is asking me to give the images of dog. So now let me predict those things. So suppose we are giving them a hat and a dog. So it had the data of hat and a data of dog. So it try to predicting the pic- pictures from in it. So it this works in steps. So keep in mind this will help us in generate pictures from ComfyUI. So this works in steps. So first step is it's generate the whole denoisy image. Then second step is it's predicting the noise and try to removing the noise from it. Then second step it's also removing. Then you're seeing it's try to give it as the images, denoise image. Then mm, slightly less, and now step 4 it's uh, good image. So this is how stable diffusion works. So currently in a open source model, in a open source spaces, there are lots of text to image generation model, but some of the famous ones are Stable Diffusion, Flux, and Hydream. Hydream is the one of the latest model which releases last month only, and Flux is one of the its releases last year's, and it got popular and uses in a production level quality. So uh, these are the open source models and Stable Diffusion. So Stable Diffusion is a model of company called Stability AI, and Flux is a model of company called Black Forest. So these are the models we can use. So for our testing purposes, and in this video, we'll use Stable Diffusion because it's the n- uh, starting of this ComfyUI and whole open source model. Okay. So this is how it. So basically, I've taken these things to explain you better. That's why I've taken these in this diagram, Miro diagram. But you can read a full article on this article from Stable Diffusion Art. You can read this full article to understand things better. I'll share this link in description. Okay, so our first part is done, how Stable Diffusion works. Now, second is what is ComfyUI. So basically, ComfyUI, there's a company called ComfyUI that's a node-based interface that uses open source and closed source models, then try to generate the images, audio, video, but primarily it's uses for images and videos that are production ready. So it's mostly used in that scenarios. So how you can install this? First, click on download. See, I'll tell you. If your computer, most of our computer, that machine that we are using, laptop, PC, is not enough to handle the complexities of the ComfyUI because these models are heavies and put take lot of RAM and VRAM. That's why I would suggest you would not choose to work on locally if you are not PC. So I suggest you, if your PC local machine is not had a one compatible like A5000, then don't use it. If your Mac has M3, M4, you can try it, but it's too slow and make your PC too slow. That's why I would suggest. you use virtual clouds. I'll tell you the workarounds. So if you have that locally machine heavy, then I'll tell you how you can install. So there's an installation guide from ComfyUI. You can see this system requirements. So how you can download the things on your locally. So just click on downloads for Windows, download for Mac. It's saying requiring M3, M2, M1, M3. But trust me, I tried this. It's not work. It's not that great on M2, M2, M3. And for Windows, saying NVIDIA graphics card. My PC is NVIDIA graphics Windows, but it's not that enough. So workaround is you use cloud machines like Jarvis Labs, AWS. There's also one called RunPod. So you can use any of them. So basically, these models will charge you on the basis of cloud GPUs you are using. So for ComfyUI, so how you can use this? So I'll tell you on Jarvis Lab, most of the process are same on each and every uh, cloud GPU. I was telling you. So first go to their templates, then select the ComfyUI. Then here you can see. So I'm in India, so it's showing money in the Indian currency. But if you are in US, UK, then it's showed you in dollar and pound. Okay, so I was telling you, so for text to basic workflow, you can use A5000, which is enough. You can also use RTX 5000. If your local PC is enough to RTX 5000 or A5000, then you can use ComfyUI locally, which is your 7 core CPU, 32 GB RAM, and 16 GB VRAM. But I would suggest you'll use at least 32 core CPUs, 24 GB VRAM, because it runs smoothly. Okay, so how you can run these workflow on cloud GPUs? Suppose you on Jarvis Lab, first select the A5000 Pro, select the storage you want. So for testing purposes, you can see at least I want 50 GB. But keep in mind, once you have taken the storage, it won't allow you to reduce. So first start with lesser storage and then gradually increase it. And I'll tell you one more benefit of video test, YouTube video test. I'll tell you one more benefit of. Okay, so our instance is running. So to run the ComfyUI on a virtual, you need to click on API and click on this API button, and this will open a virtual PC ComfyUI. Okay, so start delete this part. So tell you. Okay, this is Q. Okay. So this is a basic ComfyUI dashboard. How this is works. So this is a node-based workflow. So I was telling you, okay, I'll tell you one more benefit of using these cloud GPUs. So the one more benefit is when you click using these cloud GPU, they have pre-installed models and workflow that you can use. So you don't have to build it from scratch. Don't worry, we'll build the workflow from scratch to understand you go better. So if you can browse the workflows, you will see these type of workflows that are uh, available on ComfyUI. So you can see image generation workflows. So our image generation workflows load in. I'll delete this. And So you can use these type of workflow, image to image workflow, two paths. So you can upscale your images. You can use Flux Funnel. So these type of workflow you can use. Okay. So this is the benefit of cloud GPUs, but there's a downside. It will cost money. So yeah, because your PC is not that enough to generate the images. So that's why you need cloud CPU, but let it be. Okay, so first that then we talk about our images works in this tab. First it forward diffuse, reverse diffuse, and then predict the noise. Then how it work in ComfyUI. So there's a node based backends. There's node called KSampler, which is you can use KSampler, but starting at the start use the KSampler. Okay, now this is the starting point of our workflows. Case sampler. So here you can see it's asking for models, positive, negative, and latent image. So if you remember, we have talked about that it predicts how it image generate. First, it take the noisy main and predict the noise. So this is the that part, predict images, predict latent image, and predict the denoise. So first we'll connect the models. Okay, so how you can there's a so now let's model connect the model. So this is how. So there's a load checkpoint. So load checkpoint is a node that connects our model to model. Now these now we have to connect a prompt. So the prompt is clip text encode. This is for prompt. Now this is so if you use Midjourney and all, they have two types of prompt, positive and negative. So you can use first this is our we can take this is our text box that use prompt. So we can drag and drop second image, and this is our negative prompt. And now how we can connect this? This is we can connect clip to clip. And now suppose we are thinking ki, okay, suppose we are using this as a positive prompt, then we can connect this as a positive, or we are treating this as a negative, then negative. And what is this latent image? Latent image that we talked about. So first click on this and click on empty latent image. So what is empty latent image? Empty latent image is this one. If you can see, this one is our empty latent image that we are using. So so in this Comfy UI, this will first generate the empty latent image of a width 512 of 512. Or best size is how many latent images generate. So let's say one. Now, now it generate the latent image. We need a VAE decoder that decode the image that latent generated. So it's in this empty latent image goes to I'll tell you first. Now we need a VAE decode that decode the images. Now let's preview image. This VAE goes to this VAE. I'll tell you the logic. Okay, so logic behind this, there's a model. Okay, so now you say this is first step. There's a model. So in this, you can select the models. Now this part is our second step. So this is second step. Here it generate it take the prompt. This is third step. Third step, it's take the model image, is take the prompt, is take the empty latent image, and try to predict the images and throw the images to VAE decode. Now what does VAE decode do? Now VAE decode do this thing. VAE decode the noisy image take and convert that noisy image into a picture. So suppose now let's say we'll select our model with stable diffusion. You can, let's say, stable diffusion base model that stability has. Now we'll suppose a cat wearing a red hat. Let's say this is our prompt, and suppose is we can say blurry text. Now in this case sampler, there are two to three things we need to think of. First is steps. So we talked about these steps. So these steps generate images. So how many steps we need to require a clear image? So if we are using stable diffusion, then we need 15 to 20 20 steps, 50 to 30, but ideal we can keep it as 20. And CFG is classifier free guidance. So basically, it does the creativity. So the model we are using, how much creativity it should take with the prompt. Understanding? So how much creativity? So it's lower the CFG means the model has a higher width and it can generate images that is not related to prompt. And higher the CFG, that means it's related to prompt. If we increase the CFG more, then you try to generate prompt and then the model collapse. These are the basics. So we need to find the amalgamation of these things. So 7 or 8 is fine. So we'll take it 8. Sampler is Euler and scheduler is normal. So suppose now what is this denoise? Denoise is 1. 1 means 100% denoisy image. So in this step we talked about what is the image we are taking in the start to predict the image. So this is the 100% denoisy image that we are taking to denoise it and to generate our prompt image that we want to. So let's run this. To run this workflow, we need to click on this Q button, and first it take load the model on ComfyUI. Then second step is take the prompt. Third step is take the denoise image, and the fourth step it take at the fourth step try to denoise the K sampler, and the last step generate the images. So see, it generate the images a cat with the red head. Now, why it generate this type of image? Because we haven't told them the system that we need a realistic cat. So here we can, in the negative prompt we can type cartoon blurry, and here we can add realistic. At the first time it will take some time because it take the model. Now see a cat. Now it's generate the image of the cat face. So a cat wearing a red hat in the garden. See, so it's messed up with the quality, but let it be because it's the stable diffusion. We can use real viz. So we can use is this time real viz because it's this model is try to generate realistic images. So when you change the model, it will take some time to load the workflow because it has the heavy models or 6 GB, 7 GB. So it's first time take the time to load the images model. Sorry. So now see, this time it's try to generate the realistic images. Now, one more thing to keep in mind. So we are using this stable diffusion Excel. So if stable diffusion Excel work with 1024 with 1024. So we need to keep in mind these basics um, to keep in mind. So is SD 1.5, which is Stable Diffusion 1.5 model, which generate good images with 512i. Now you are seeing this is pretty much the realistic image with the red hat. Now I'll tell you the one thing, the steps we talked about. So to see how the steps work, we need to fix the seed. Or now what does means fix the seed? This means now we have fixed the seed this from this time onwards. So now let's generate the image. Now we have fixed the seed. Now this time onwards, when we try to generate the image, it will generate the same image because we have fixed the seed. See, it will generate the same images. Now we can see how this image is generated. So suppose let's see we can use at the step 3. What we can see how this image stable diffusion works at every steps to understand better. Okay, at which step it give me the best quality of images. So you can test it out. So see, at the step or 3, it will generate the denoise image. So you can see. So whenever I try to tell you, see, this is the red picture. So first it's trying to predict the red. So it's red and it's trying to capture the uh, model. So okay, so the cat will look like this, and the posture is this one. This try to generate the picture and all. So this is how it's trying to generating these things. Let's see how this will look like at step 7. Now see, it now it's trying to generate more denoise things, and this has the red, but there's no element of garden, no element of the grass and all. It's not trying to predict. It's trying to predict the images head, and now you can see these hair, mustache of cat and all. Now let's see these steps at 12. So how this is how you can test it out and see. Okay, now it generate the cat image and the head, but there's no background in it. And if you compare this, this is our image, and this is image our step. So see, this is our image as step 3. This is our step 7. This is step 12. Let's see at step 16. So this is how you can play with these things and see. If you see step 16 and step 20, pretty much same, but step, there's a finish is missing. So in this step 20, there's a color guidance, there's a brightness and in it, but step 16 is missing that finish. So you can keep that try. Let's see, let's try this at this step 25. So this is how you can play with these things, and you can see now step 25. There's a similar image, nothing changed. Let's try to break the model. Let's try to generate this as step 50. What it will do. So higher the step, higher the it will take the time. So this is I was suggesting you using on a cloud GPU if your PC is not that enough, because your PC will break at this step. So the step 50 is good. Let's try to generate this as step 100. What will it generate as step 100? So this process is calling the break the model to find out the best output that we want from models. So this is how these things works, and this is how you keep trying, testing and trying. but as a basic label, um, but for stable diffusion, keep it steps at 20 to 30, and this is the our average. You can keep it. See, now it will try to generate the same picture at 100 steps. So now it's not generating the picture that is enough. See, now it's generated a cherry on this mustache that we don't need. See, so this is how things are breaking. So at the 100th step, these are breaking the steps. At 50, this is over postured. So this is how these things works. So So this is how a text to image generation model work. So you can see test it out at your own. See what is text to image workflow. Try to generate these things. Try to play around with these sampler name scheduler. Basically, these are the things. These are the maths. Basically, scheduler means how it will control the noise. You can keep over it and see the what is. So basically, sampler is a sampling it affecting the quality. So these are how denoising works of the schedulers, how denoising work, and samplers, how your quality of the images works. So you can play it with around and let me know in the comments how you like the video. Hit the subscribe button. The next video is will dropping soon. I'm planning to drop 2 videos per week, and after 5 to 7 videos dropped, I'll take a live session on will decide once the 4 5 the basics of ComfyUI covered, so you can ask me your questions there in the live class. So till then, hit the subscribe button.